Hi everyone, today we're going to introduce the FGC Team China's robot in the season 2022. So firstly, let's talk about the chassis. Is there anything special about how you arrange the wheels and the motors?
Yeah, so let me show you guys. First of all, we use two Omni wheels in the front and two Omni wheels in the back. And that allow us to put the center of rotation of this bot in the exact center of this robot. And that really helps us when it comes to aiming because it's more intuitive in this way for me that the robot rotates around its center. Second of all, I also want to show you guys how we fit a shaft collar in between these two sprockets. And we cut the inner part of both of these sprocket because the shaft collar that REV gave us was too wide and it can't fit through in between. And this is because, why we did this is because for this specific motor, although it has a locking screw in the motor itself, this motor mount is getting in the way of accessing that screw. So that's why we didn't go with securing the shaft with the built-in locking screw. We went with these two shaft collars to lock this axe around this C-channel. Okay, so here you can see it's an intake made with two large sprockets and a lot of rubber bands. And this is our first generation intake. It's effective at intaking, but let me grab a ball here. Thank you. And it is good at intaking the ball into the storage room itself, but it's hard to demonstrate because in reality this intake spins a lot faster. But this is our first generation intake, and although it is good at intaking one ball at a time, when it comes to more balls intaking at the same time, it's hard to do that. So that's why we came with the second generation intake, and that's why this robot is here. This is our 2023 robot, and this intake is so effective, that's why they adopted it, and they literally harvested this part from our 2022 robot because it's too hard to make. Well, I think we have a tutorial posted online about how to make this intake, and if you're interested, you can go out and check it. And this intake is effective because, first of all, it's more rigid than this one. And second of all, this intake is shaped so that each of these gaps here fits exactly one ball. And it can intake multiple balls at a time because unlike this one here where multiple balls will get jammed because rubber bands share the same tension, here the tubes doesn't. There's a lot of tubes around this row. That's why we went with the second gen in the final robot. And also a little detail that I want to show you guys is here you can see that there are another roller here that is smaller. And this roller here helps the ball to get up to the platform here because, well, our platform is quite high and it just can't get up there without these rollers. And by the way, these two side of rollers, they share the same motor here and connected by sprockets on the side.
Okay, so next let's walk us through the outtake. After the ball enters the robot, how does the blender work and how does it go into the shooter? And finally, how does it get shooted out of the robot?
Okay, so as you can see here that we have two blenders here. And these two, they work together to push the ball into the tunnel that's the shooter tunnel that's here. And here are little doors that block the ball from entering the tunnel when we don't want it to. And let me open up this to show you guys a better view of the shooter here. So when we want to shoot a ball, we open the door here, open the two latches here, and together the blender pushes the ball into the tunnel. And this is our first stage acceleration roller, which runs at the lower target velocity and pushes the ball into the tunnel and launches it to the second roller that's up here, which is running at a much higher target velocity, and that is able to shoot the ball out and into the target funnel.
Also, I noticed there's a panel around here. Can you help me explain how it functions?
Okay, so this panel here that's connected to servo serves the purpose of extending our storage space. So this robot is designed with a purpose in mind, that to intake as many balls at once and shoot them all at once. That's why we designed this door that can be opened to extend our storage space. And in theory, this can take up to 20 to 30 balls at a time. Also, these webs here and here, they help to secure the ball in the storage room itself and not get jammed between the shooter or the rollers.
So finally, let's talk about the Ascent.
Okay, this is definitely the most complex part in this robot. The whole setup Ascent system is controlled by servo. And here is the first servo that controls the launch of the rubber slider and the rails here, guarding rails here. And when the servo releases both contraptions, first the guiding rails is powered by rubber bands here and is swinged backwards by the rubber band. And the set of sliders, though they look weird and unusual because they're not connected by rubber bands, they used to have rubber bands here that acts as an updraft force and push the whole set of sliders up. This whole set of sliders, because of its use of rubber bands, is able to get up to its full length in around 0.7 seconds. And as it extends, the dead wheel here, as you can see, they used to be wrapped around by these wires, and now the dead wheel is freely rotating and releasing the wire here as the slider goes up to its maximum height. When it reaches its maximum height, here it's a block that pulls the end stage downwards, which is controlled by two servos here that is connected to this roller, which is dragging this pieces down. And when the piece is dragged down, this hook is hooked onto the bar that's here. So we arrive at the last step, which is the roller here that's connected to the hook. And this roller is connected to a core hex and a REV hex motor. Together, they pull the wire down and make the ascent possible. When the robot is ascended to its maximum height, here is a magnetic sensor that will trigger this Hall probe here, and that will mark the end of the ascension and kill all the motors.
And also, I noticed there's a guide rail around here. So how does it function?
Yeah, you remind me that this one here is a guiding rail that serves as a slider because the high pole and the low pole of this competition is on the same side. So we want to climb to the high pole. We don't want to get jammed by the low pole here because our pulling point is in the center. So if we don't have this guardrail here and we just pull directly upwards, because the lower pole and the high pole is on the same line, we will get jammed here. That's why we have this sliding rail here that when the robot leans backwards, the low bar gets blocked by this pole and as a result slides downwards so our robot doesn't get jammed. And that's why the backside of the robot is a nearly straight line because this whole surface is gonna get scraped by the low pole.